This is going to be a video about little do-it-yourself home automation, especially about energy registration and measurements. And I think we should start with a little video out of this is my electrical cabinet. And here is the measurement units that uses an M-bus. There's something from the 70s. This is Norway, so we are not really advanced. There is a LED here that's flashing. It gives you a pulse, or 2,000 pulses or something per kilowatt hours, or kilowatt hour. So here I just have, I'm detecting the flashing here, and it's connected to my PLC. But we can look at this video and do a little pause and stuff here too, maybe. So here you can see the flash. Here's the Raspberry Pi running Node Red, little spare fuses and stuff. Fuses, and here is the PLC. This is the Schematic S5, and you can see the flashing here of the light around here. This CPU is an old CPU. So if we pause it here, this Schematic S7 300, old CPU, but this one has been running since 2002 with no errors on it. I had to replace the power supply to it, but the CPU, I have exchanged the CPU. I have an older Type 2, so this one is probably, let's say it's been running since 2005 or something, for 20 years. Yeah, about, I think that's what it is. Now there's not a lot of spare parts available. This one is going to run for another 10 years. That's probably with this home automation system you can buy, is the quality is really low. They don't last long, but this stuff here is designed to run day out, day in for 30 years. Yes, and what we have is some relays here it's just to run a ventilation and stuff like that. I switch it off on fire and so on. And there are terminal blocks. Relays, 10 ampere relays that use for sockets and lights and stuff like that. So I have 50 of those, and there's a dimmer for light and more terminal blocks. And then here, if we go a little, I have a display in my entryway. AliExpress, it's a nice display, but the fan is awfully low, so you need pretty much hearing protection here to use it. But I have to do something, get a low-speed fan to cool it. I have perforated the casing in the back here for convection heating, but that's not enough. But now if we look at the home automation screen here, so this is a Norwegian, as I'm Norwegian. So this is energy. This is it's the energy consumption, but it's watt or kilowatts. And so it's energy. It's effect. Basics. So this is what I have, and then you have some temperature, outside temperature, indoor sensor, a couple, and here's light intensity outside. So I control the lights and on the outside light intensity. But here's the energy metering that I have. So here is what I've used here. I've charged my battery electric vehicle on the BMW i3. And here I did use my dishwasher. And this is the total consumption I had since I started up in the house here. 2002, I think we got this stuff, and here is consumption per hour. So now we are here. So now it's a little cold, so I have my floor heating on. So I'm consuming close to a kilowatt or something. Here's the daily consumption on the Tuesday and so on, and here's the monthly consumption. And we are in May. So let's say the date now is the 14th, so I should probably use a little over 1,000 kilowatt hours. But now I've also turned down my heating in the floor. It's not switched high. It uses the indoor temperature to just lower the temperature, and also compensates a little for low outer temperatures, and then a heat pump running too. There's not much more. You can control the switches in the house, first floor, second floor. We have a couple of controllers here, and some is the floor heating. So that's the temperature in the entryway, and has automatics and control for 20 degrees. Now I have, this is my minimum control value is 2 and has the minimum 4. And then what do we have? We have alarms here too. Fire, test sirens, test my doorbell. There's also fire detectors all over the house. Yeah, properties, you can set some properties when the light should be on the lux and so on. Parameters for the controllers, and then we have got an event system where we have this is my infrared detection, outer entryway and the inner and whatever. I've been in the basement, the light and so on. And okay, I can clear those. I can store them to a file. I can mail an email. Of course, here is fire and stuff. I can get an email. And also when we are away, if I get an IR detection, there's someone in the house, I get an email on that too. Yeah, that's the email for the file. And I can get the last one, but I can also have it. That is reset by the operator. I reset it. So this was a quick video. It's not that long. It's a little do-it-yourself house automation. Especially focus on my energy consumption. It's expensive to buy from the energy providers. You can buy units too, but then you need converters for this old M-bus. That's not easy. They should have used ordinary TCP/IP or something in these so you can connect. So what I can do now is to control a lot of this is that I can use my Raspberry Pi and then you just get energy data from some online provider about, let's say, hourly rate for energy or something, and then they can control. I could switch off my battery electric vehicle too, just by cutting the power to my charger, but I wouldn't do that. Then you would have to look into the BMW protocol for the charger and stuff and communicate with that. But then again, in Norway, you can just charge your BV during night, and the current isn't that expensive because there's a lot of people are charging the BEVs overnight. The battery electric vehicles overnight, it's going to be more expensive. But for now, I'm just charging night time. And then you can do a lot like burglary alarms and stuff, and cameras and so on the house. But the main point here was the energy registration. I mean that the tax we have is it cost me on AliExpress I think $1 or something like that to buy. There was a bag of them, so I have quite a few of them. But we need spare parts too. And the PLC I had and spare inputs I had. But what you could do is, of course, you could use this detector connected to the Raspberry Pi directly, and I use Node Red. And then you have, of course, components that can read the inputs, general input for Node Red, and you can connect them there, and then you can just write JavaScript programs to do what I did in the PLC. But then, of course, Raspberry Pi is not high quality hardware, so it will probably not run for 30 years. It could probably not be updated for 30 years either, but a PLC, a schematic PLC, can be. And the thing is the program here is all written in high-level language, so it can be ported to the new PLC hardware, so even you can port it to Beckhoff or Codesys hardware or whatever. And the I/O too should probably be new, but that isn't that expensive. You can even run, of course, a PS on the Raspberry Pi if you want that, but still the Raspberry Pi is low-quality hardware, so it wouldn't have much. So if I want the house to live another 30 years, I should probably upgrade my hardware now. As it's 20 years old, it's going to live for 10 more years to get new schematic hardware. But the schematic is really high-quality hardware. You can program it in high-level language to use continuous function chart for the configuration like I do. And it's easy to maintenance and stuff. And you can have all that on a virtual machine, so as long as I use VMware to run it, so as long as VMware offer you some runtime for all operating systems you can still use. Of course, it depends on the network too, but I think TCP IP is going to live for quite a few years more. So, okay, short video. Hope you enjoyed it.